So the do now said, compare these fractions by writing greater than, less than, or equal to. Could I have a quiet hand volunteer for number 1 who would read us their whole inequality, please? Let's see here. Read us the whole inequality, please. Samantha.
3/8 and 5/8.
Good. And how do you compare them? 3/8 is
less than 5/8.
Beautiful. If you agree with Samantha, give a woohoo. I can see their mouths moving, Samantha. And Samantha, I'm actually going to have you do number 2 as well while you're unmuted.
Five tenths.
6/12 is blank 5/10.
Less than.
Oh, good. So because the denominator was bigger, you're thinking about that?
Actually,
sorry, I caught you off guard. You had only said number 1 and I kept you going. Do you want to phone a friend for help?
Sure.
Sure. Okay, raise a quiet hand. Samantha's going to call on you.
Sana.
So the second problem?
Yes, please.
Okay. 6/12 is equal to 5/10.
Great. And how did you know that, Sana?
Because 6/12 is equal to 1/2 and 5/10 is equal to 1/2.
Beautiful. Using the power of, say it with me, the equivalent fractions rule. Very good, ladies. I'm going to do numbers 3 and 4 just for speed. So make a connection if you use this strategy for number 3. I was thinking 2/3 and 2/5. So I pictured them in my head. And I thought, well, if I had 5th pieces and just 2 of them, they're pretty tiny. But if I had 2/3 pieces, those are pretty big. And that helped me know that it was greater. So you might have done a different strategy. That was just one way to do it. Same here. You can make a quiet connection if you did this same way. When I looked at this one, 3/8 and 4/6, I saw right away, well, 3/8 is less than 1/2, right? Because 4/8 is exactly 1/2. And I knew 4/6, well, that's greater than 1/2 because 3/6 is exactly 1/2. Oh, I'm seeing some connections. Awesome. So that helped me really quickly know 4/6 must be greater. Could I have a volunteer to do the last one? Talk us through what you did, please. Gabby.
So I knew that, so the fractions were 70, 100, and 4/10, and I knew that 70 was greater than 4, and the denominator doesn't really, it doesn't really matter when you're comparing fractions, so unless you have the same numerator. So I said 4 is less than 70, so it's 70 is greater than 40. Wait, did I say that right? 4 is less than 70.
4 is less. So you were just looking at the numerators.
Kind of.
Okay. So you are correct that 70 hundredths is greater than 4/10. But I want to check on one thing you said. We have to be careful. You can't just look at the numerators, and let me show you why. If I had 70 hundredths versus let's see, if we did 4/5, right? You might say, oh, 70 is greater than 4. So maybe this one's greater, but if we use the power of the equivalent fractions rule, I know that 5 times 20 is 100. So if I do 4 times 20, I'd get 80. In this case, 4/5 is greater, even though, so we have to be careful to always consider the denominator. Can you go back to this one, Gabby, and tell us how we could use the power of the equivalent fractions rule to help us be sure?
So So 10
Mhm.
times 10 is 100.
Good.
And then 4 times 10 is 40.
Beautiful.
But 40 100ths is still less than 70 100ths.
Very good. Excellent. And Gabby did multiplication. You could also divide numerator and denominator by 10, right? 70 tenths. I'm seeing some connections on that. 70 tenths, 70 hundredths is 7 tenths, also greater. So once we have the same denominator, then we're really in business. It's easy to compare. Any burning questions about the do now? Okay, just for fun, if you did the early finishers, hold it up on your screen so that we can see some of the endless possibilities you came up with for less than 1/2. Ooh, that's a big list, Sana. Oh my goodness. Yes, Gabby. You're muted.
I was just saying I did the early finishers.
Oh, awesome. Yeah, good, good. Yay, way to take advantage of that. Okay, so let's move on to today's lesson, which is going to be all about multiples of unit fractions. So now that we have our fractions brains warmed up, let's remind ourselves, thanks for your enthusiasm, what a unit fraction is. A unit fraction is a fraction with blank in the blank. Raise your hand if you remember how we'd fill those in. May.
1 in the numerator.
Awesome. Beautiful. So everybody, I want you to type in an example of a unit fraction. I'll do an easy one, 1/10. Everybody type into the comments, what would be one example you came up with for a unit fraction? And May, make sure you mute again. Good. 1/13, 1/20, 1/5, 1/100th, 1/2, 1/8. Excellent. 1/12, 1/236. Oh, cool. Look at this list going on. Okay, now shift gears. Now I want you to type in a non-example. So something that's not a unit fraction. Good, Samantha. I like yours. I can't even read that really big number so fast. Good. So now type in a non-example. Good. 5, 6, 3/2. Ooh, that was even an improper fraction. 5/4, 2/4. Good. Oh, that's an interesting one. You're right, Lila. It's funny because 2/4 is a non-example, but 1/2 would be an example, even though they're equal. That's really interesting. Whoa, Tessa, you have a really large numerator. Good, ladies. So you get the idea. So now, okay. So for this next problem, there's going to be a part on your journal that asks you to draw a picture. So I want you to pay attention to how we do this. So if it said 1/4 plus 1/4 plus 1/4 equals 3/4, we know kind of repeated addition is the same thing as, type it in if you remember, repeated addition is the same thing as, or you could type the symbol or the word. What operation? Yes, multiplication. Good. So we could also say that as 3 times 1/4. It's going to give us the same answer. And we were doing that a lot yesterday. Now, here's how these would look in a picture. If I had, I'll do bars. It would be fine if you wanted to do circles for your fraction pieces. I like to do bars. And now I'm going to split these bars into how many pieces. Type or hold that number up on your hands or type it in the comments, whatever you prefer. I'm going to split, if I'm showing these, I'm going to split these bars into how many pieces. Tessa's got it. Carlum's got it. 4 pieces, right? Because I have to pay attention. My denominator was asking for 4 equal pieces. Good corrections, ladies. So I like to split into 4 by cutting in half and then cutting in half again. Oh, did that work? 1, 2. Yeah, perfect. Cut in half and cut in half again. Cut in half. Nope, I did 5. 1, 2. Oh, no, I did 4. Why did that look like 5 to me? Woo. Okay. 1, 2, 1, 2, 3, 4. Okay. So now I have fraction bars that show 4th pieces. Thumbs up if you're with me. I see, Sana. That makes sense. Okay. And now I want to show 1/4 plus 1/4 plus 1/4. So type in the comments, how many pieces will I shade in on each bar? Type it, or hold up your fingers. Good. I'm only going to shade in one on each bar. That gives me a total of 3/4. Okay, so I saw some girls holding up 3, and I see why you were doing that, because the answer ultimately is 3/4, but on each bar we put 1. So that's how you would illustrate it in a drawing. You also might, or you will in your journal, see this on a number line too, right? So if I had, I'll put, this is not perfectly equal, but I tried 0, 1/4, 2/4, 3/4, 1. If I had equal pieces like that, and I'm showing 1/4 plus 1/4 plus 1/4, I'm going to start at 0, hop 1/4 plus 1 more fourth plus 1 more fourth, and it lands me at 3/4. So those are 2 ways to show these problems. Any questions about that so far? Gabby. And then Claire, I'll come to you after. Nice.
So do we have to do both or just one?
It'll say in the directions in your journal. It'll tell you.
Oh, so
it tells you. The reason I showed you both is because I think one of them shows you a number line and the other one shows you a picture. So just be ready for that. Claire? And Gabby, mute, please.
Why couldn't you have shaded in 3 of the boxes on the top row instead of the 3 going diagonal?
You absolutely could, Claire. So this would be like a totally separate way to do it, right? So here's one option. Another option was just to have your forced pieces. If you're doing that, I'd try to shade them in different colors so I kind of know what you mean, right? Okay. Like I might have 1 and 1 and 1/4 to get 3/4. Okay, just to make it really clear. But you're right, you could do that all on one. Good, great question. And then Claire, you'll go back on mute, please. So now we get to practice. Oh, no, we're almost to word problems. Almost there. I was going to say now we get to practice with word problems at the bottom of this page. But first, we're going to look at our multiples. Remember, I said today's lesson was all about multiples of unit fractions. Sorry about that, ladies. Coming back. Thanks for those who are saying don't worry. We'll be back soon. Okay. Yay. We're back on now. Sorry about that. Thanks for being so patient. And thumbs up if you can see the screen again. Perfect. Okay. And remember, we're recording this, so if it froze for you at this point, you can always go back and rewatch. No need to stress about it. Yeah, I'm not sure, Delina, but again, we have the recording, so we'll just focus on ourselves and who's here, and they'll be good to go. So you will, in your journal, see several problems phrased like this. Write these fractions as multiples of unit fractions. So let me show you the first one, and then I'll ask you to help me with the next one. So 3/4, I know the unit fraction I want to talk about is 1/4 because I'll keep the same denominator and just put a 1 in the numerator. And it's the same thing as 1/4 times 3. That's the whole number we need. Perfect. And that's what we just saw in that visual, right? That those were the same. So now let's try this one, and I'll give you a little more opportunities to participate. So if I had 4/5 and I want to write it as a multiple using multiplication of a unit fraction, 4/5, my unit fraction is 1/5. And it's going to be times what whole number? Hold up on your fingers or type it in the comments. Good. Good. I'm seeing 4. Awesome. Okay, let's do one more. On this one, 9/16, can you tell me what the unit fraction would be? What would the unit fraction I'd want to use in my equation for 9/16 be? And you can just use the backslash. Perfect. Carlum's got it. You can just use the backslash for your fraction. Excellent. 1/16 times, hold it up on your fingers or write it in the comments. What's the whole number going to be? Nice. I'm seeing some good comments coming through. 1/16 times 9. Now, another way we can say this, and rub your ears so I know that you're listening. Perfect. You can stop rubbing them. 9 is a multiple of what unit fraction? Oh, sorry, if I were saying this, 9/16 is a multiple of what unit fraction, then your answer would be just 1/16, right? So if I said 9/16 is a multiple of what unit fraction, now, as always, I have to RTQ, and this time the question's asking me for a unit fraction, so my answer is just going to be that unit fraction. Good, exactly, Delina. Okay, questions about writing fractions as multiples of a unit fraction. Now we get to apply it in a word problem. So this one, I used Ayla in my example. Ayla, and this example might make you hungry. Apologies for that. Ayla is making the ultimate ice cream sundae. She uses a 1/4 cup of hot fudge, 2 1/4 cups of Oreos, and 3/4 of cups of M&Ms. How many cups of toppings did she use in all? So I'm going to underline my question. I want you to go ahead and say the question out loud while you're at home. How many cups of toppings did she use in all? Glad I saw your lips moving. So I've read to understand. Now I need to make a number model with unknown to help me answer this question. And Delina, I'll come back to you later, I promise. Raise your hand if you want to share out the number model you would use. What would your number model be? Claire, can you help us out with this one?
I would use 1/4 plus 2/4 plus 3/4.
Perfect. Oh, sorry, I wrote it wrong. 1/4 plus 2/4 plus 3/4. And it wanted with unknown, Claire. So what else do you have to do?
Question mark.
What do I need before the question mark?
Equals question mark.
Beautiful. Awesome. So now I could solve this. 1 plus 2 is 3 plus 3 more, going to give me 6/4 cups. Write in the comments if you could reduce 6/4 cups. What's that the same as a mixed number? Write it in the comments, please. What's 6/4 the same as a mixed number? Nice. We got it down to 1 and 2/4. Can you reduce that even more? Write it another way in the comments. 1 and, excellent, Megan, you girls got it. 1.5 cups. All 3 of these are the same. They're equal. They would all 3 be acceptable answers. Now, going to give you the same scenario, but a different question. How many more, so I'll leave the problem up here so we can see it. How many more cups of M&Ms did she use than Oreos? Say that question with me. How many more cups of M&Ms did she use than Oreos? And who would like to set up our number model for this one? Sana.
Fourths minus 2/4 equals question mark.
Excellent. Took the number of M&Ms the number of Oreos and has her unknown. And if we solve that, 3 minus 2 gives us 1/4 a cup more. Okay, and that answer seems to make sense. So let's do one more. This one, we're finally going to get to use our multiplication of fractions. The container comes with 5 cups of hot fudge. If she puts a 1/4 cup of hot fudge in each sundae, how many sundaes could she make before she uses up all the hot fudge? So let's underline our questions. How many sundaes could she make before using up all the hot fudge? Here's a big hint. The setup to this problem is very similar to the setup to the try this in your journal. So as you know, the try this are a little bit tricky. They switch it up a little bit, and that's the same here. But you have all the tools in your toolkit to solve it because you know fraction multiplication and you know how to read a problem carefully. I see you, Lila. Let me finish this one and then I'll come back, okay? So if this asks how many sundaes could she make before she uses all the hot fudge, my unknown is really saying, I'm saying if she had 1/4 in each times some number of sundaes, then that's going to equal the 5 cups, right? So remember how when Sana and Claire were setting up equations for us, it was kind of just you were solving for the unknown. Now the unknown is in our equation. 1/4 times something is going to equal 5 cups. So now to solve this, I'm going to do it a step further. 1/4 times something equals 5 whole cups. 5 is a little tricky for me to work with. So I am going to say 5 is the same as how many fourths? What would go in that numerator? Type it in the comments if you know what would go in that numerator. We're going from 5 to some number of fourths. 5 is how many fourths? Remember, good. Remember, fractions are just division. So we say, well, 20 divided by 4 equals 5. 5 is the same as 20/4. Excellent. Okay, now, can you see this clearly? 1/4 times some whole number is going to equal 20/4. So your answer, your unknown, is 20. Woo, she could make a whole 20 sundaes. Oh my gosh, she could feed the whole class. Ah, that'd be amazing. I wish, right? So that's a little different technique. I want you to pay attention when and really RTQ, and that will help you when you go to solve. Okay, Delina and then Lila. I know you both had your hands up. Delina, go first. Okay, no problem. Lila, go ahead.
So I know a different way to solve it.
Please, I'd love to hear it. We'd love to hear it.
You can also draw 5 whole circles and then divide them into fourths. And then you can count how many fourths are in each circle and you'll get 20. And then you can also do, you can multiply by, oh, wait, sorry, I forgot what else I was going to say, but yeah.
That's such a great visual. Thanks for that, Lila. So Lila pictured it, and she said, okay, if each sundae has 1/4 of a cup, well, it's going to take, to fill up 1 whole cup, it would take 4 sundaes. So this was, and you could skip count by 4s, right? 4, 8, 12, 16, 20. That's a great visual. Thank you for telling us about that. Okay, any other burning questions that are going to help the whole class. Otherwise, I'm going to make one more announcement, and I would stay on with girls if they want to do some journal problems together. But first, any burning questions that you think will help the whole class? Okay, so my announcement before I let some of you go, and we'll do handshakes and you can go. My announcement is I've started correcting your Seesaw assignments. So thank you for all your efforts to do the work and put them on Seesaw. And thanks for being patient with me while I get to them all. One thing I noticed, and a system we're going to do, is sometimes you will have corrections to make. Just like you would put stickies in your math journal when we were in school. Sometimes there'll be a circled problem on Seesaw too that I need you to go back and look at. And to do this the best way, here, rub your ears so I know you're listening. Thanks, ladies. What I'll have you do is actually, if you see a circled problem, circle that go back in your actual math journal, circle that problem in your math journal, rework it out in your math journal, and then just add another picture to the Seesaw page that had or to the Seesaw assignment that had your corrections. I think that'll be way easier than you trying to use the pen tools in Seesaw when we don't have a lot of space and it's going to get really messy. So just correct circled problems in your journal and then add a picture. Okay, and we'll keep, if I hear anything differently, that's going to be an easier system, I'll tell you, but right now that should be the easiest. Thanks for the thumbs up for confirming that sounds good. So at this point, if you feel like you are confident at multiplying unit fractions and ready to go get started on the journal on your own, I'll have you unmute. If you would like to stay on and do some journal problems together, keep your screen muted, and we will do that in just a moment. So Carlin, is this one that needs to be the whole class, or do you mind if we wait?
No.
Okay, perfect. So let's do May 1st. Ready, May? Yep. 1, 2, foot. Bye, May. See you at 1.
Are you going to stay on?
Okay, Lila, you ready?
Yeah.
Okay, Lila, you ready?
Yeah. Have a nice day.
Bye, Bye.
Bye.
Okay, Claire.
What? You froze.
Okay, Claire.
I think she's still frozen, Claire.
Yeah, she is. So. Shh.
Sorry, Claire.
Okay.
You there? Okay, let's do it, Claire.
Yeah. But.
Oh my gosh.
Oh.
I started leaning. Ready? Foot.
Spin.
Oh my gosh. I gotta start fresh, Claire. Sorry. Foot, spin. Bye,
Yeah.
Claire.
Bye, everyone.
Bye, Claire.
Bye.
Okay. Tessa, you're ready? Head. Bye, Tessa. And Sophia.
Bye.
Hope to see you guys soon.
See you at 1. Bye, Tessa. Okay, ready, Sophia? Bye, Sophia.
Bye, everybody. Bye.
Yeah. You ready to go? Okay, ready? Woo! I like the seated foot. Bye, Gabby. See you at 1.
Bye. Thank you.
You're welcome. Thank you.
Oh, bye,
Okay.
Sina.
Ladies, since there are just 4 of us now, you can unmute while we do a few problems. I'm going to start sharing my screen again. While I do that, Carlum, do you want to ask your question?
Sure. I really have no question.
You just want to stay on and listen, Delina?
Yeah.
Yeah, perfect. Great idea.
So do I.
Awesome.
It's kind of about the question that we were just doing.
Let me pull it back up. Yes?
That one. So I found another way.
Oh, please. Let's hear it.
So you also could do, so like 5 equals 1 over 4 times b, or like whatever question marks or whatever.
Yep.
And then and after that, you could divide 1 over 4 by 1 over 4, and then you get 1.
Yeah. Okay.
And so basically, you have, and then on the other side, you could do 4 times 5 to 20. And question mark or b equals 20.
I love it. So you said, 5 equals b times 1 over 4. And then you just kind of knew that if you multiplied by 4 on both sides, it keeps the equation equal because you're doing the same thing to both sides, right? And you said, well, 1/4 times 4, that's just 1. So that's just going to leave me with, cool. Good algebra.
Nice.
I have one more question.
Please. And then Delina, we can do the try this together.
So you said like on C side you like cracked it or something, like the pen or something is kind of messy. What if you have like an Apple Pencil? Like, can you use that?
Yeah, I have one.
So I still, even though I have a stylus and like use it on the iPad, sometimes it's still messy. So I just think it will be easier for you to actually make the corrections in your journal. And plus that way, then your math journal is filled with like all your problems corrected. Okay.
I agree.
Yeah, I think it'll just make it a little easier for us, okay?
Okay.
Let's do the try this together. And if you
Which
are you
page?
all ready game for that? Yeah, what page are we on? Let's see. I bookmarked it. 235. 235.
Wait, what page?
235.
Okay.
Okay, so let's read it together. Jason has 6 pounds of almonds to put into bags of trail mix. He wants to put 1/5 a pound of almonds into each bag. How many bags can he make? So I'm going to underline my question. How many bags can he make? And now I need to think about, well, what is the equation I want to set up? He has 6 pounds. He's going to put 1/5 a pound in each. How many bags could he make? Could anyone tell us the multiplication equation you'd set up to show this problem? And I'm going to pull back up this guy so we can be thinking about how we just did that one. What would be the multiplication equation you'd want to set up here? Carlum, you got an idea?
Yes. So you could do 6 equals 1 over 5 times question mark.
Beautiful. 6 equals 1/5 times something. And now we know that 6, let's have you type it in the comments so that everyone has a little time to think of it. 6 is the same as how many fifths? AKA, what times, what divided by 5 would equal 6? Good, 35th. Because 5 times 6 equals 30. So 30 divided by 5 would equal 6. You with me?
Yeah.
Samantha, you with me?
Yeah.
Okay. So now that I know 6 is 35ths, Samantha, can you tell me how many bags he's going to be able to make?
30.
Yes, you got it. Good. Each of those bags has 1/5 in it. And if we had 30 of them, then he'd use the whole 6 pounds of almonds. Okay. I'm going to have to get on my other call in a few minutes, But are there any other burning questions?